All right, so I'm back. So last time I told you to get through these other two gear ratios and write the explanations in there. So now I could go over them and you can see if you got them right. If you didn't get them right, go ahead and change it, but figure out, why is this not right so that you know what you're doing, not just to get the right answers. And hopefully you did this and you're not just writing down the answers as I go here. Get the camera a little better. Okay, so the first one, we said, remember, rule number one, output comes first, input comes second. Now, the output, how many teeth? 48. How many teeth on the input? 6. So how do we reduce that? Well, let's see. 6 times 8 is 48, right? So 6 goes into 6 once, 6 goes into 48. Oops, sorry, that's a 1. 6 goes into 6 once, and 6 times 8 is 48. So we've got a gear ratio of 8:1. So there's your gear ratio, all reduced. Now, our explanation. I said, remember, don't write this whole sentence thing out. So what's the first thing? Look at rule number 2. If the first number is bigger, we increase torque, right? First number is bigger. So that means torque goes up, speed goes down. Now, second part of that is figuring out how many times each gear spins. Remember, the smaller one's going to spin faster. So just like I did the last time, if we flip-flop our numbers, this now, oops, I didn't write them. We got our 1 here, we got our 8 here. So if we, well, now our output spins 1 time, our input spins 8 times. So the output 1 time to the inputs 8 times. That would be your explanation. Now, look at that though and ask yourself, does this make sense? Did I do it right? Do I have them in the right order? Because we just said you're increasing torque. Now, if you're increasing torque, which gear is going to spin faster? If you're increasing torque, your input's going faster, right? If you think about riding your bike, when you're increasing torque and you want to go up a hill, you set it so you pedal really fast, but your tire goes slow. So let's see. The output is spinning less than the input, so that would make sense. That would increase torque. So we got the order right. If you got them flip-flopped, then you just switch them around, okay? All right, we're going to do the last one here. I'm going to leave the O and the I. And our last one here, our output has 20 teeth. Our input has 16. Now, this one becomes a little bit tricky, and I didn't give you any hints on this one like I usually do to kids in class. So maybe I'll give you a second on this one. But first, let's reduce the easy way. Okay, so we know that 4 goes into both of these equally. 4 goes into 20 5 times. 4 goes into 16 4 times. You've got a gear ratio of 5:4. Now, you could leave it like that, but it's really nice to get a gear ratio down to where one of the numbers is a 1, because it's easier to think about, okay, if this gear spins 1 time and the other one spins 1.5, okay, it's easier to think about that than like 5 times and 4 times. So it's good to get it down to 1. Now, how do we do that? Well, an easy way is, first of all, let's say, and you can do this on a calculator, but let's say the old-fashioned way, this means 5 divided by 4, right? 4 goes into 5 1 time. I go 1 times 4 is 4. I got a remainder of 1, right? What do you do with that 1? You put it over this number here for a fraction, right? So we have actually 5:4 means 1 1/4. So you could write, say, 1 1/4 to 1, but normally what you write when you write gear ratios is decimals, and 1/4 is what? 1.25. So you could write a gear ratio of 1.25 to 1. If you take out your calculator and do 5 divided by 4, it gives you 1.25. So you have 1.25 to 1. So one gear is spinning one time, the other one is spinning 1.25. So you're increasing either torque or speed by just a little bit, right? Now, can that sometimes be a very significant amount? Yes, for sure it can. Okay. So let's do our explanation. What's going up? Look at rule number 2. If the first number is bigger, we increase torque, right? So once again, we have torque going up, speed going down. Then, how many times they spin? You flip flop them, remember? 1.25 to 1. So our output spins one time. Our input spins 1.25. Look at it, ask yourself, does it make sense? If we are increasing torque, the output has to spin slower. Look, the output 1, input 1.25. Perfect. Okay. All right. So I'm going to do a separate video next because I'm going to show you the packet on my screen and talk about it.